Solve Smart. Make sure you subscribe to the channel. I'm going to solve a problem, and the problem is about partial derivatives. And the problem is a function which is given by w, which is equal to x squared plus y squared, where x is equal to x plus t and y is equal to x minus t. So the question is saying you have to find the dw over dx and also dw over dt, where x is equal to 1 and t is equal to 1, and again x is equal to 1 and y is equal to 1. So the second part of the question says we have a period which is equal to 2 pi times the positive square root over the length all over the g, where g is equal to the acceleration due to gravity, and a pendulum bob is moved from the canal zone, or a pendulum is moved from the canal zone where the acceleration due to gravity is equal to 9.78 meters per second square to Greenland, where acceleration due to gravity is equal to 9.82 meters per second square. So because of the change in temperature, the length of the pendulum changes from 76 to 76.2 centimeters to 75.6 centimeters. So the question is saying you have to approximate the change in the period of the pendulum using total difference. So let's look through the solution. The solution is saying before you can tackle this question, you have to use the chain rule. So using the chain rule, you have to state the formula first, that the formula is equal to dw over dx, which is equal to dw over dx multiplying dx over dw plus dw over dy multiplying dy over dw. You have to really pay attention to the formula. And again, you'll find these derivatives from the general function and also the functions given. So you will find dw over dx, which is equal to 2x and dx over ds, which is equal to 1, and also y is equal to s minus t. You find the dy over ds, which is 1, and the dw over dy from the general function, which is also equal to 2y. Then again, we substitute our values into the general equation of the chain rule, and we will get 2x multiplying 1 plus 2y multiplying 1, and the final answer will be 2x plus 2y, or 2 into bracket x plus y, where x is equal to 1. From the question, x is equal to 1 and t is equal to 0, and s is equal to 1 and y is equal to 1. So you substitute in your values, or you put in your values, and after putting in the values you get 4. That is the answer for the w over dx. That is the partial derivative of w over ds. That is 4. Then again, we proceed to find the w, or the partial derivative of w over the partial derivative of t, using the same idea from the chain rule. So you state your formula and you find the derivative of these functions, and after finding the derivative we realize you get 2x multiplying 1 plus 2y multiplying minus 1. Then you finalize your equation, then you get 2 into bracket x minus y bracket close. Then you substitute, or you put in your values, you will get 0. So for the first part, the answer for the w over ds is equal to 4, and the answer for the w over dt is equal to 0. So let's move to the second part of the question. The second part of the question also says, we are to approximate the change in the period of the pendulum using total difference. So we are going to use the same differential, the derivative idea, the idea from the derivative, to solve the second part. So you say the differential of t is dt, which is equal to the partial derivative of t over the partial derivative of g multiplying dg plus the partial derivative of t over the partial derivative of L multiplying dl. So you proceed to find your derivatives, and after finding your derivatives you realize that the dt over dg will be equal to minus 2 pi over 2 multiplying the positive square root of L multiplying g minus 3 over 2 dg plus 2 over 2 pi multiplying 1 over root g, and again multiplying L exponent minus 1 over 2 times dl. So you finalize your answer or your equation to get minus pi multiplying root L over g exponent 3 multiplying dg, which is equal to pi multiplying L over g multiplying L dl. So you say dg is equal to 9.82 meter per second square minus 9.78 meter per second square, which is equal to 0.04 meter per second square. Then again dl will be equal to the difference between 75.6 centimeters minus 76.2 centimeters, which is equal to minus 0.006 meters. So we have find the value for dg and also dl. So we say that g is equal to 9.75 meter per second square multiplying L, which is equal to 76.2 centimeters, which is equal to 0.762 meters. So we proceed then find for dt. So the value for dt will be equal to minus pi multiplying the positive square root of 0.762 meters all over 9.78 meter per second square all cube multiplying 0.04 meter per second square plus pi times the positive square root over 1 over 9.78 meter per second square multiplying 0.762 meters. And all of this I'm multiplying, we introduce a dot here, you are multiplying negative 0.006 meters. So our final equation, our final answer will be minus pi multiplying 0.0014 or 114 plus 0.00220, which is equal to minus 0.00334 pi s. So This is the answer for the approximate change in period. The answer for the approximate change in the period. Answer for the approximate change in the period of the pendulum using the total difference. Make sure you subscribe to the channel. This is SwapSmart.